generate. Okay, and you say, okay, we have those two created for us. Okay, so I hope we've all been able to generate or create at least one directory or the two of them where we can keep our raw data or where we can keep our figures whenever we are able to generate them. Okay, are we all together? Any questions, any difficulties up to that point? Okay, good. So if we have none, that's quite good. So a good thing or a good way to know where you are, if at any one point you feel you don't know exactly where you are, R has an inbuilt function to get the path, excuse me, to get the path of where you are, and that is by typing. Okay, so at the bottom where my cursor is here, you can be able to type get, as I'm typing, get WD. If you say type get WD, all right, and with two brackets, opening and closing brackets, and you type enter. Okay, I'm going to reduce this a bit so that we can see. It's able to tell you where you are. Okay, it gives you a path on what your working directory is, so you are able to get a bearing of exactly where you're working from or where you are within your computer. Okay, so it gives me, I'm here, 1CG, Becker, tutorials, data carpentry files, and I'm inside data carpentry. Okay, so that's one very good command to be aware of. It is able to help you know where you are within your project, okay, or within your files. All right. So the other thing I'd like us to look at, all right, is seeking help. How do you get help for a command or something that you don't know? Okay, and that is, as I told you, whenever you're doing something, it will jump. So if it's plots or packages or help, so how do you get help for a function that you want to know? Okay, so if you want to know something, for example, the most common arithmetic functions that we want to probably know about is, let's say, for example, mean. What is mean, and what does it mean, or how is it calculated? Okay, so at your console, whenever you have the arrow pointing forward and the cursor is blinking, it means R is ready to receive a new command. Okay, so I want to get the help of mean. All right, so if I type question mark and the word mean, okay, what you first of all notice is, because R has an inbuilt function for tab completion or auto completion, if it's something that within R, it will bring for you a list of things that are within R that start with mean. And the first one is mean, the one that is highlighted here is mean. Okay, and it tells you it's a generic function. Okay, calculation of mean. Okay, the arithmetic mean. And if you press enter, okay, automatically on your bottom right, it opens up the help tab and it brings up the manual or the instructions for what mean is. Okay, so at the top here you can see there is mean, it's written mean, and it tells you this is a base. In curly brackets you have base, meaning that this is something that is inbuilt within R. You don't have to install the package or the library, R automatically comes with that function or that command to calculate mean. So it tells you, it gives you description. It tells you it's a generic function for the trimmed arithmetic mean. It tells you how to use it. Okay, so it tells you you have to write mean, and then within brackets there's an X, and these dots will tell you optional, like they're optional arguments that you can give to R. Okay, so that's how you can seek help. That's the first method. Okay, the other way to get help is if you come directly here to this tab called help, where you have the search, sort of the search icon here, and there's a cursor that's blinking. You can type. So for example, let's say we want to know what is median. Okay, again, because of R's inbuilt auto-completion or R Studio's inbuilt auto-completion, you have two commands within R that have median. So let's click on the first one. It brings for you the help of median. Okay, it tells you what it is, compute the sample median, how to use it, the arguments, okay, that you can give to that command or that function so that it's able to calculate for you what you're looking for. Okay, it also gives you the details, in-depth details, and the values for the arguments. Example X that it needs to have in order for it to run. Okay, and then this dot dot, as I said, this could be potential further arguments that you would want to give to R. But basically that's how you get help. Okay, the other cool thing is maybe you're thinking of something that you would want to do within R, but you don't know if it's within R or if it's possible to do it within R. What you can do on your console, okay, is if you type 2 question marks and maybe say you want to know about Kruskal-Wallis test or something like that, you can type Kruskal. Okay, one, it brings you those available commands within R, but you can also say you don't know about what Kruskal is. So if you just type Kruskal and enter, okay, on your help tab on the bottom right, it automatically brings for you the help pages that are within R that include the Kruskal word that you asked for. Okay, so you can choose which one you want to do. So we have the most obvious one here, which is the Kruskal-Wallis rank sum test that you might want to do, or others that are also available within R. Okay, so one thing we have to note is that with help, whenever you're looking for help for a function or a command, R, if you're working offline, will only be able to provide for you help or manual pages for functions or commands that are within the packages you have installed in your current R. Okay, as I said when we started, R can do a million things. You can analyze data of so many types and so many forms. So for the packages that you have installed, okay, as I said here, if there's any function that is within these packages that you're searching for, R will be able to give for you to bring it. But if you search for a function that R does not have within its libraries or within the base functions, it won't be able to open for you, and right, you can probably be able to look for it online. All right. So we've looked at automatic code completion, and that is to mean that if you type something and it is within R, okay, that it is available within R, as we said, for example, mean, R will automatically bring up a list of available commands or function within R that can be done. And then you can be able to, sometimes you don't have to finish writing it, okay? So if you just write MEA, it brings up anything that starts with MEA, and you can choose. By using your up and down arrows, you can move from one to the other. And once you are at the one that you want, you press enter, and it will automatically be completed for you on your console. But you can also do this within your script or within your source, where you can be able to type your code. So if I type min, you see the same thing happens. It brings for me a list of every command that starts with MEA. So again, you can use your up and down arrows to move between the list. And once you identify the one you want, press enter. It automatically completes it for you and puts the two braces, opening and closing braces, that are required for you to run a command. All right. Are we together up to there? Any questions?
So, Bernice, there are some few questions here. The first question is, are you able to rename your folders? That's a bit, can you be able to rename the folder? And yeah, I think that's the only question that has been asked.
Okay, cool. You can absolutely be able to rename your folder. Okay. You can rename your folder, maybe not directly here, or you can also do it here, right? If you choose, if you click on it, all right, at the top here you have rename selected file or folder. Okay, if you can all see that, you can do it from here directly. I can rename it. So maybe I can write this in start with a capital letter and say data raw, and that's done. It's renamed. But you can also do it within your computer and it will still change. So if I go to, let me bring this up. All right, so if I go inside here, I have this, okay, the one we've just renamed right now. I can also rename it from here, okay, and just take it back to what we had, data raw, and it renames it. All right, and we'll automatically be able to see that even within your files under R, it has been renamed to what we had before. So yes, you can absolutely be able to rename your folders. Any other question?
None.
Okay, cool.
Hello, I have a question.
Yes, please.
Why the double question marks for cruise call and not a single one like me in min?
Okay, good one. So when you put one single question mark, you know exactly what you're looking for, and you're looking for the help of, or the manual page or the description of what that function is. All right. So if you look at my console, when I type one question mark, min, and press enter, okay, it automatically opens up the documentation, or it directly goes to the manual page or the help page for min. Okay. However, when you do the double, it's because you probably want to know if this function is available within R. Okay. You're not sure if it's available within R. Okay. And you want to see if there are any commands or any functions that include the word crucial, or I don't know, maybe Pearson correlation. Let's do that. Let's see if there's anything. Okay, so you see what happens on your help tab. It opens up a list, and it brings up a list of help pages that have that word that you've written, the Pearson word. Okay, it doesn't go directly into opening the help page like we did with mean. It opens up a list. So maybe this is just something you're thinking in your head. Can I do Pearson's correlation within R? So I type Pearson. It brings me a list of all the commands that have Pearson. So if you can see, this one has Pearson's chi-square test. It brings up anything that looks like Pearson within R, or that is available within R at that moment. Also because it depends on the packages that you've installed within your R. Does that answer your question?
Yes, thank you.
All right, good. Okay.
Kindly may I ask?
Yes.
Seeing as the links after the Pearson pairing, I see the links there. Do you have to be online for this to be generated, or even when you're working offline, you can receive this information?
Okay. So what I've said, to make it a bit clear, is that the help pages that you'll directly be able to interact with R, if for as long as you have that package installed or you have that library within your R session, we'll look, I don't know if, yeah, I think we'll be able to look at packages, but you have done this before. If you all attended the preliminary sessions, you are able to install the package tidyverse, and you are also able to install the package Ggplot 2, right? So when you are installing Ggplot and tidyverse, you are able to see how to install packages. So for any package that you have within your R, if you open a function that is within that package or a command that is within that package, you can easily be able to have access to the help page, even when you're offline. Okay, even when you're offline. These are readily available. So as long as it's within R, the base R that comes with the core packages within R, and for any other package that you've already installed into your R environment, you can easily be able to have it within your R. It does not require for you to be online. Okay?
Okay, that's clear. Thank you.
All right, good. Okay, so we have looked at the concept of working directory. We have looked at the concept of seeking for help and how you can be able to learn more about functions. We've also seen how you can automatically complete a code or a function by typing it, and R will give you a list. We've looked at that. So the other thing that we might quickly look at before we take a short break will probably be how to access instructions for how to use a package or to do certain tasks. And they are a great way for learning by example, which means you can follow along, okay? And they are accessible through a function in R called browse vignettes, okay? So I'm going to type that within my console. So if you type browse, again, auto completion comes here, and you can see it's right here. So browse vignettes, it tells you it's a list of available vignettes in HTML browser with links to PDF or LaTeX no web source that you can be able to use. Okay, so if I type that and complete it, all right, it opens up a list of tutorials that are available for various things that you can be able to do within R. Okay, quite a number of things that are available. And if you click on it, you can like click on any of the links, you can be able to look at it. So there are quite a number, and you can use this to your advantage to learn a lot of things. Okay, so for example, there's one here on dplyr. Dplyr is very good with data structures and manipulation of data within your R. Okay, so that's a good resource for learning quite a lot about R. All right, so I think this would be a good point to take a break. We have one more thing I would have liked us to cover within this, but I'd like us to cover this when we actually start writing code after the break. So unless you have any questions, we can take a quick 5-minute break. Anyone needs to get a drink, use or do anything, we can take maybe 5 minutes and then continue into introduction to R. Mike Festus?
Yeah, sure, that's okay. Yeah, 5 minutes. So the time is 10:23. 10:24. We'll resume at 10:29.
Okay, cool. And if you think of any questions while you're on your break, feel free to type them and we can look at it when we resume. So yes, let's meet back here at 10:29. Thanks.
Bernice?
Okay, I think we can resume.
Yep.
All right, good. So let me share my screen once again. Okay, so everyone can see my R screen. Mike, can you all see my screen? Can you see my screen?
Yes, we can.
Okay, cool. All right. So I want us now to look at R and do a few things within R. So I'm hoping everybody has been able to open their R and you're within your R. You probably have been able to look at your script section or your source section where my cursor is on the top left. So from now on, I want us to be working within this, within our script, so that we are able to save everything that we are doing. Okay. All right. So let's see at how we can be able to look at output from R and how can we run a command in R and we have been able to write something within our R environment. Okay, so simple arithmetic. Let's say 3 plus 5. Okay, how do we run this code within our console? But we've saved that within our script. Okay, so if you simply press Control on your keyboard, Control and Enter at the same time, you can see that within your console, you see the answer, which is 8. You don't see the answer within your script, but the code that you have run still remains 3 plus 5. Okay. The other option that you can use to run your code is if you look here at the top, you see 2 green arrows. You have the first one that tells you, if you hover on that green arrow, it tells you run the current line or selection. So if we are on that current line and we press that green arrow, it runs our command. Okay. And the second one, you can have R rerun your previous code region. You see this arrow here with saying behind, so you can rerun what we've rerun before. But those are the two most common ways to run a command from your script. So either you type, or on your keyboard you press Control Enter, okay, or on the line that you want to run, put your cursor on that line and then press the green arrow facing forward to run that current line. Okay, or even if you have a line that has a long piece of code, if you select and run, it will be able to run. Okay, so
Bernice,
yes.
there's just a quick question.
Mm-hmm.
There's one participant, she missed out after the break. How did you get there? I think the opening of the script.
Okay, yes.
Yep.
All right. So what you can quickly do to open a new script is, if you look at where my cursor is, you have the plus button here. If you're working within RStudio, you have the plus button here. If you press this, because it's a plus button on an empty, it's on top of an empty file, okay, like an empty document. So if you click on it, it gives you a list of what new thing do you want to open, okay? And we want to open a script file, an R script file. So if you click on it, it opens for you a new one, okay? The other option, I remember for the lady who might not be able to use RStudio, if you go to File, okay, and say New File, all right, New File, you can be able to open a new R script. You should still be able to get that, okay? So for myself, I will close these two because I'm not using it. But for this first one, just as an example, if you want to save it, okay, if you want to save it, because you can see both of them are red, all right, both of them are red. If you want to save, you have this button up top here that says it has the icon for saving that's available on most Windows operating systems, the small save button. You can say save current document, okay, and it takes you directly into your working directory under the project that we created, and we created data carpentry folder. You can save it, okay? So let's say it's an introduction. Remember not to have spaces within your names, always safer. Introduction to R, okay, and you save it. So once you save a document, it becomes black, all right? It automatically becomes black. But if you type something on it, for example, let's say 12 divided by 7, it becomes red again, if you look here, because it has unsaved changes, all right? So as long as your document has unsaved changes, the name of your script or your code file will be red. And then you can also easily save it by the keyboard shortcut for Control S. So Control S will still save your document, okay? So that's how we got into the new script file. I should have explained that when we started. I'm using this one for me because it gives me cues on what we are doing and what we need to cover, right? Okay. So I hope we are all there. We have a new script file. We have been able to save it within our folder. And just to confirm, if you look at the bottom right, you will be able to see the new one, that new script file that we have saved, introduction to R.R. So the .R tells your computer that this is a file that needs to be opened using the R software, and it will automatically open it with RStudio if you're to open it next time. The other good thing is that you can see exactly when you saved it or created it and the time. All right. So this one that we've just generated has been saved today, March 24th at 10:33 a.m. Okay, so we have that. So I'm going to continue working on the one I had initially opened. Okay. So one very useful thing that we want to be able to learn is how to assign values to an object, or in many other software, it might be known as a variable. Okay, objects versus variables. So, for example, we want to save, say, the weight. My weight is actually 55 kgs. Let me save that into a variable. So if I type weight in kgs, okay, I want to store the actual weight in kgs, that is 55, inside the variable or the object called weight underscore kgs. So how do we do that? We do that using it's called a reassignment, okay, or an assignment, sort of an assignment syntax within R. So the less than arrow, okay, that arrow that we use in mathematics to mean less than, and a hyphen. Okay, less than and hyphen. So this is called the assignment syntax, okay, within R. So you can use this, and I say within weight in kgs, I want to store the value 55. All right. We said we can run that line or run a command using Control Enter. All right. So you'll notice within your console that it was able to run for you that particular command. Weight in kgs is 55 kgs. Okay, is 55. And if you look at your global environment, you can see you have that value saved. All right. So what we were doing is to save the value 55 within an object called weight underscore kg. So next time, I don't have to type 55. Okay, what can I do? If I type weight kg, again, the beauty of R in auto-completion, if you have a value that has been saved, like we have in our global environment here, and you type it, it is available within your list of auto-completion that you can use. So if I click tab, it completes that variable. And if I run that line, Control Enter, look at your console, what does it tell you? It's 55. Okay. So of course, maybe for this particular part, it doesn't make sense because 55 is such a small value. But if you have a list of long values that you want to save, you don't want to keep typing a list of values. You can save them within an object or a variable. Okay, so that's very useful. All right. And as I've typed here, in most other software, objects are known as variables. And particularly for this session and within R, objects and variables are synonymous, and you can use the two interchangeably. Okay. We have noticed as well that when you run a command to assign a variable or to assign an object a value, R will not print anything. Okay, it simply tells you in your global environment that now you have a value called weight underscore kgs, and the value inside it is 55. It's only one, so it's displayed here. Okay, so what can you do when you have a variable? You can actually do calculations with a variable. So, for example, I have weight in kg. Okay, I use tab auto completion, and I know maybe I want to know how much would this weight that I have within my weight underscore kg be in pounds. Okay, I don't have to type 55. I know within weight underscore kg is the value 55. I want to see how much it will be in pounds. So usually weight in pounds is 2.2 times the weight in kgs. So let's say I want to multiply. So if you want to multiply in R, you use that sign, that is the asterisk, okay, times 2.2. I want to see how much my weight would be in pounds. Control Enter, and you see you actually have an answer. So it took the value within weight in kgs, which is 55, and multiplied it with what I gave it, 2.2. And you have your answer. So my weight in pounds is 121 pounds. Okay. The other thing you can do, you can reassign the value within your weight in kgs. So initially, remember what we had assigned to weight in kgs is 55. All right. And this is nice because you're doing all this within your script. So if you just go back up a few lines, you see you had assigned 55. But we can actually just reassign that quite easily. If you type weight in kgs, you can reassign it a fresh value. Remember, you can use that, you use that syntax for assignment, the less than and hyphen, okay? And we can assign it a new value, let's say 57.5. and you run that. Remember, you run it using Control Enter on your keyboard or the Run tab there, which is the forward green icon that you have. And we have reassigned that. If you look at your global environment on your top right, you'll see that the value has changed. It's no longer 55, it's now 57.5. So we've been able to assign that. Okay. So what then do you think we can do again? Because we want to make sure that in case of anything, we are able to save our code. Remember to save your code. So periodically, every few minutes, like you do with your Word document, so that in case lights go off or something, you are able to go back to where you are. Always remember to do a save. So a simple control save on your keyboard, Control S, will save your code. So always make sure you are saving your code. So you can directly go here to save as. If you want to save it somewhere else, but if you automatically do the Control S, it will save in your already directory that you've already chosen. Okay. So I want to bring to your attention on this script that I'm using, you will see a difference in those lines that begin with a hash, okay, and those lines that do not begin with a hash. So having comments within your script is very important, fundamental for yourself currently, your future self. If you come back to this script, you want to know what was going through your mind while you were running this code, okay? Or even if you share your code, share your script, you want somebody else to understand why are you running that code? Why did you write it like that? Okay? So you will notice that if I start a line with a hash, the shade changes. And to R, this specifies that this is a comment. And it automatically knows that this is a comment, it's not a command. So if I start it with a hash, I can write, okay, reassign the value, okay? So what I was doing in the next line here was to reassign the value within weight in kgs. So next time I come, I know I reassigned the value at this line because I can read it as a comment, okay? So it's very, very important that you have comments and you comment them usefully. And that is to mean so that you are able to come to it even next time and know what you are doing. Okay? All right. So if you see within my script, I started with creating objects in R. I know this is where we were creating objects. If I come next time, I know what I was doing. Okay? And why I was doing it. I was explaining about objects and variables. That's why I have that line and those lines of comment there. Okay? So it's important that you have comments within your code. All right? Any questions up to there?
Yes, Bernice, there's one. Is there a setting or option for auto-saving?
Is there a setting or option for auto-saving within R? Wow. Is there really? The one thing I know that if you want to exit your R, it will always ask you if you want to save your current changes to your code or your R environment. I, however, do not know if there's an option to auto-save unless you actually save it. Unless you guys know. Any of you know if there's an option to auto-save?
No.
Yeah,
There's no auto-saving
yeah.
option. Yeah, best of my knowledge.
me neither. I also don't know of an option to autosave the document. Okay, it's not like Windows, the Microsoft
Yeah.
Word that will autosave for you. This one you actually have to autosave. You remember when we started, we said there's no pointing or clicking, you know, within R. You have to understand what you're doing in R in order for you to run a command or for you to do something. Okay,
Okay.
so
Another question is,
mhm.
what is the difference between the object and a variable?
So this, as I explained here before, okay, in some other tools, they will call variables as objects. Okay, so really I think it depends on within the programming language you're working with or a software that you're working with. Okay, within R, they are interchangeable, they are synonymous, they are the same thing. An object or a variable is, you know, a name or a container for values that you want to save for ease of reference. Okay, it might be very different in a different software, so really it depends on the context in which you're working. Okay, all right, so I think we can move ahead
Yep.
to functions and their arguments. All right, so functions are, let's say, is a script that you can use, and it automates more complicated sets of commands, including operations, assignments, and many others. So functions are predefined. Okay, predefined in that when you say mean and you call a function mean on a series of data sets, you know exactly what it's going to do. All right, in that sense it's predefined. That's why it also has a help page, because it's been written or it has been developed to do something else or to do a set of um, analysis. So it's predefined. They can be made available into R by importing R packages, which you already did, for example with tidyverse and ggplot. And a function will usually take one or more inputs called arguments, like we saw when we were calling a help page for mean. So when you call a function or you call a command, it will return a value, which is what you're looking for, right? A value or a result. So a typical example that maybe we can use is, say, for example, for weight in kgs, which we know we reassigned to 57.5, we can reassign it, okay, to a value that has been calculated by calling a function. All right. So let's say we want to do the square root. Okay. I have auto completed there to know if there's to see how it's written. So I know it starts with SQ. So, and you can see here that it tells you the only argument. So here the only argument we have within is x. So it will compute the absolute value of x, which is the square root of x. Okay, so let's say I want to do the square root. It auto completes for me, and I say I want to do the square root of 10. Okay, when I run that value, control enter, that's the square root of 10. Okay, you see it's been reassigned. So what we did first of all within this, we did two things. We did the square root of 10 with this function, square root of the value 10, and we reassigned the result of the square root of 10 to weight in kgs. So remember we said we can also do a selection. I only want to see what is weight in kgs. If I run only that, control enter, I will see that weight in kgs is 3.16 because we've reassigned the value of the square root of 10 to that. Okay, so different functions will take different number of arguments. square root only takes one argument because it simply gives you the result of a square root of a value. Okay, I see someone raised their hand. Rispa, do you want to?
Yeah, thanks, Bernice. My question is, I always see you have a space after like weight in kg, then that greater than or less than sign. So what happens if you don't use a space? Will it affect?
No, it will not affect. But for somebody to easily read your code, or even for yourself to easily read a code, it's good. It's good practice to have spaces. I also
Okay.
don't have to have empty lines after here, but I put them so that I know where I am. It's simply formatting for yourself and for others. Okay, I can still do this without a space. I can do that, but it's so crowded. I don't know what is what, which ends where. Okay, it will still work. Okay, it will still work if I do that. But for ease of reading code, it's just better to have spaces. It's something I personally practice. Okay,
Okay.
I would advise it just so that you're able to read your code very easily. All right.
Okay. Thank you.
Okay, so as I was saying, functions will have different number of arguments. Okay, so this one we've run called square root has only one argument, and that is the integer or one value that we want to do. So others, for example, will have more than one argument. Okay, so for example, we want to do, let's say, round in terms of rounding off to the nearest number. Okay, so round, as we can see, has two arguments. It has the argument x and the argument digits, which is equals to 0. Okay, so when I say digit is equals to 0, it means I want you to round it off to a full number. Okay, and then if maybe I change that, so let's try this. So let's say 3.14159. Okay, so if by default you can see what it tells me up here is you need your x, which is your value, and then the next argument would be digits is equals to 0. So if I'm not intending to change the next argument, I could always just run that command as it is, and it will go with the default for digits, okay, which will be a full number. So it has rounded off that value for me to 3, if you can see in your console. But maybe we can add an argument and say digits, okay? And you see the beauty of auto-completion of R. If it is an argument that is valid for that function or that command, it will auto-complete it for you. So if I tab complete that, I say I want to round off this number to the nearest 2 decimal places. Okay, and I run that line. It gives me 3.14. And this is why it's important to understand that you have the help pages available for you. All right. So remember we said you can open help pages by typing round with a question mark in front. If I run that, it opens up for me the help page automatically here on my bottom right. So it explains rounding off numbers, and you can see the different arguments. So x with digits 0 is by default. Okay, so x is a numeric vector that you can give it, and digits is an integer indicating the number of decimal places you want to see. Okay, so whenever you're unsure about what a function does or the different kinds of arguments that you can use to manipulate that function, open the help. All right. So this is good because R also assists you to understand what you're doing. So when you're running a command or a function, you learn more about it and you understand what is going on in the background of that command by reading the help and understanding how it works. And you can play around with it until you get to a value. You see, this is the beauty of writing down your code and actually giving commands to R as you want them. I can easily shift this to 3. Say I want to run round with 3 decimal places. So you can test things around and see and save it once you have something that you think is good for you. So if I easily run that with 3, you see I get 3.142 in your console. So R is very versatile. Okay. So the other way to also know about the different arguments that are within a function is to run args. Okay. So args, as you can see, it displays the argument names and corresponding default values of a primitive function. Okay. So if I say args, let me tab complete and say round. All right. I run that. It tells you the function is x. So you need x, which is your vector, and it has another argument called digits. So note also that arguments are separated by a comma. All right, as you can see even in the result here. So if I run this without a comma, for example, what do I get? 1, you can see the x here. RStudio automatically tells you or intuitively gives you a hint that there's an unexpected token digits and unexpected token equals to, because it does not understand. I mean, you have not typed it correctly. So R intuitively tries to correct your code for you, correct the syntax, or correct sometimes even the spelling if you do it wrongly. Okay, so for example, if I try and run that code, I get an error. Error, unexpected symbol in round, and then you give the number and digits. R does not understand this, but it's very helpful in trying to tell you that this is an error. And what is the error? I experienced an unexpected symbol. So if you go back to your code, you can see you have not separated your commands. So R is intuitive in that way that it tries to help you write your commands and check your syntax so that you're doing it the correct way. Okay, so don't be afraid of errors. Very helpful. And if you get an error the first time, it's quite okay. That's what you'll always be getting, probably because you're trying to learn things, do things better, and errors are part of data analysis. The same way mistakes are part of life, you learn from them, right? So when you get an error, don't be afraid. Read the error and find the mistake. R will always tell you where the error is. Okay, so if I correct that, my X disappears, and now I can run my command without a problem. So errors are fine. They're part of data analysis. They're part of life. You learn from them and get better. Okay. All right. So now let's go into looking at vectors and the different data types that you have within R. Okay. So a vector is the most common and basic data type in R, and it is the workhorse behind R. It is composed of a series of values, which can be numbers or integers or characters. Characters meaning they are values that cannot be interpreted as a number or a numeric value with decimal places. Okay. And so this is where variables and objects become very powerful. All right. So let's say we want to save the weight of, I don't know, a set of girls or boys. So I'll say weight G and assign that to, so a list of weights. So how you can be able to assign more than one value to a variable or an object is by using the C with brackets. So within here, if they are plain numbers, as we said, numbers or integers are understood just as they are. I can type a list of them: 50, 60, 65, 82. And I save this. So you see in your values, in your global environment, you have weight underscore G is a set of numbers, 4 of them, and you see them: 5, 60, 65, or to 82. All right. You can also be able to assign characters. Okay. Let's say, for example, we want to save the name of a few animals within the object or the variable animals. And I want to save more than one, so I'll put them within a list. And now, because these are characters and not numbers or numerical numbers that R can read, we put them within braces. Okay, double quotes, so that R understands that they are characters and it should read them as they are, as characters. Okay, so let's say mouse 1. I want to save rat. Okay, and let's say dog. All right, I save that. You see again in your global environment, you have animals, and it tells you here it's CHR. CHR to mean they are characters, and there are 3: mouse, rat, and dog. So when there are too many in the global environment, it will tell you the number. So maybe we had 50, it will tell you their characters 1 to 50. It will not be able to list all of them here. It will just maybe list the ones that can fit, the first few that can fit here. Okay. All right. So how do you know, or how do you interrogate what is inside a variable, or what is inside an object? Okay. Again, R is very powerful. So let's say I want to know how many values I have within weight. Okay. Let's try the function called length. Okay. Again, when I begin to type, it auto-completes for me. And because it's on the first one, it tells me length X. It only has one argument. It get or set the length of vectors, including lists and factors of any R object. Okay. So if I autocomplete length, and I want to know the length of weight. Okay, the length of weight. What's the length of weight? I run that and I see I have 4. Okay, and we, in actual sense, we actually have 4 values within weight. Okay, what about animals? How many do we have in animals? Okay, autocomplete, and I want to know what's within animals. Control enter. We have 3 values within animals. Okay. So the other thing we also want to know, or would like to find out, is what is the type of vector, or what is the type of data you have within an object or a variable. Are they characters? Are they numbers? Are they integers? So within R, you can still be able to find out what those are. Okay? By using the function called class. So we can see it takes one argument and it tells you it's a simple generic function mechanism which can be used for an object-oriented style of programming. It tells you what kind of or what kind of data or what kind of value you have within an object. So if I say class, for example, of animals, okay, I run that, it tells me they are characters. You can see in my console, they are characters. All right. And then what is the class of weight? Okay. Run that. They are numeric. These are numbers. Okay. So you know what is exactly inside. And then the other useful thing that you might want to do is know the structure of a variable or an object or a data set. Okay. So for example, if I do str, okay, str, as it says, it displays the internal structure of an R object. Okay. So if you want to know how the values within an object or a variable have been organized, we run this simple command called str, in short, structure. Okay. So if I run structure, can I autocomplete? Yes. I autocomplete the structure of animals. What does that look like? It tells you its character, and they are 1 to 3, so 3 of them: mouse, rat, and dog. Okay. So for example, if you had a table with several columns, it would list all of them here: character, the one that's a character, the one that's an integer, and gives you this a summary sort of how your data set looks like within your variable. All right. So we've learned and seen that vectors are the building blocks or are the background to how R works. An atomic vector is the simplest R data type, and it is a linear vector of a single type. A linear vector meaning it is a list, okay, of vectors or of values that are of the same type. So if they are numeric, they're all numeric. If they are characters, they're all characters. If they're integers, they're all integers. Okay. So we have other types of atomic vectors. One, we have logical. Okay. So a logical vector is for true. It gives you or returns for you either true or false based on a condition that you set. We'll look at that shortly. An integer is for numbers, okay, or complex, to represent complex numbers. For example, that we use for equations like 4i or 4x. So those would be called complex atomical vectors. So you have logical ones, you have integers, and you have complex vectors. All right. So we've seen that atomic vectors can be of type character, numeric, integers, or logical. Okay. So, but what do you think would happen if we tried to mix these types of vectors in a single variable? All right. So let's say, for example, we save numbers and characters within the same variable. So numbers and characters. Okay. What would happen then? Let's save several of them. For example, let's save 1, 2, 3, and the letter A as a character. What happens? Of course, R will save it. It will tell you, it will do what you tell it to do. Okay, R only as a command line tool does exactly what you tell it to do. Okay, can we use class to check what happens here? Okay, so can one of you run class and for this num character and see what the answer is? What does R tell you? So anyone who can run that, and we can see what R gives as a response. What kind of characters do we have in this value or this object that has values of integers and characters within it?
Just give me character.
Okay. It just gave you character. And it gives you character because it's not able to understand that you have numbers and characters within it. So it defines all of them as character. All right, because you've mixed the characters within it. Okay, it automatically assigns all of them as characters, because numbers can also be characters if you give them within braces. They can also be characters, and because we have a character within it, it tells you they are characters. Okay, so you've noticed that objects of different types get converted into a single shared type within a vector. And so what R internally does, it coerces, okay, it coerces the other types of vectors within a variable into one, so that it coerces all of them into a character variable. So it told you it's of class character because it coerced the numbers 1, 2, 3 into characters, because we have the character, the shared. So it shares all of them and coerces the numbers into integers and tells you it's they're all characters. Okay. So maybe we can look next at subsetting vectors, unless we have any questions. Do you have questions?
There was no question, there was just a concern. One of the participants got an error, but another participant was able to assist. That was nice of you, said Henrik. So
Awesome.
yeah,
That's
we're able
very
to go.
good. Very good. Very good. I'm happy you're learning and you can be able to assist each other, which is
Yeah,
the
and
overall goal of this. This is very good.
yeah, and also a reminder to everyone that the codes are in HackMD. The link was shared early during the training at the introduction phase, so you can also go back there and check.
Okay.
Yeah, and also the challenges that Bernice is mentioning, the questions and the answer are also in the challenge section, the HackMD.
Good. Thank you. Okay. So we have just about 2 more things to cover. So let's look at subsetting vectors. So we know what vectors are. They are the core of R. It's what R understands as different data types. So you can have vectors of different types: logical, integers, numeric, or logical. Okay. So let's say we have a vector. For example, we have the vector animals. And within animals, we have saved mouse. We have saved rat. We have saved dog. And let's say we want to also save cat. So we have four animals we've saved, or four values that we've saved there. So we've looked at, we know the length. We can check the length of that by using length, okay, of animals. So we know there are four. So let's say we only want to see one value, okay? We want to see only one value within the vector or within the variable animals. How do I do that? So how R internally stores a variable is by their indices. So if you look at your global environment, we've reassigned to animals four values: mouse, rat, dog, and cat. And you can see here it tells you their characters 1 to 4. So let's say I want to see the second vector or the second value within this variable. Okay? I say animals, and I use box braces. Okay? All right? And I say 2. What do I get? If I run that, I get rat. And when we were saving, or when we were assigning values to the object animals, rat was our second value. So as I've explained, R will save values within an object as a series of indexes, like a coordinate. So it knows mouse was at 1. So if you tell it, if I say here, I just want to see 1, it will give me mouse. It was saved at the slot as the first slot. So say I want to see the third one and the fourth one. Okay. So animals, the box braces, I want to see the third one and the second one. Okay. So it tells me incorrect number of dimensions. Remember we said if you want to give a list or more than one value, you have to place it within C, like within the C and then braces, so that R reads it as a list and not just one object. That's why we get an error. Error in animals 3 and 2, incorrect number of dimensions. It's not able to understand what that is. So if we change this and say animals, we want to see 2 of them, okay? We want to see 3 and 2. So now R will, 1, expand this, right? Expand what we have within brackets first as a list. We look at 3. It will have a list of 2, so number 3 and 2. And I'm subsetting, or I want just to see a part of the object animals at point 3 and 2. So now let's see if that will work. You see now it works. So now we have dog and rat. So don't be afraid of errors. They are okay. They only make you better. Okay. So R, just to mention, will start its indexing at 1. Okay. So R starts its indexing at 1. So if you tell it 1, it will give you the first value that was saved at 1. There are other programming languages that start their indexing at 0. For those of you who've worked with C++ or Python, you'll notice that they start their indexing at 0. So if we wanted the value at the value that was saved first, we would have said 0. But for R, because it's easier for humans to read it, it typically starts its indexing at 1. Okay. So if we have no questions up to there, we'll go to the next and use.
Bernice,
yes.
There's actually one, and I'd like Ronald to try and explain, because I didn't get it myself.
Okay, go ahead, Ronald.
Okay, I think it's an error on saving, because it appears with periodically when I try and save or when I'm typing anything, I'm just typing exactly what you're doing. Then it gives me that error. It says, let me go back to it. The process cannot access the file because it is being used by another process. So it just keeps popping on the screen as I'm typing things. So I'm not sure what that means.
Have you opened it twice?
Your volume again, Bernice. Maybe your
sorry.
mouthpiece is far
Have you
away.
opened it? Have you opened the document twice?
No, I even closed R and reopened again. So I don't know what the error is. Maybe we can go through it. I'll see how it is at the end of the session.
Okay, maybe at one of the sessions, one of the helpers can go to a breakout room and assist you with that. But we're almost done, so yeah, we can have a look at it over the break.
Thank you.
Thanks. Okay. So next, we can look at using conditional subsetting. By conditional subsetting, what we are saying is we want to subset a vector or a data set based on a condition. Okay, so we want to filter, let's say filter, or just select values within our data set that are meeting a certain condition. Okay, so for example, we can try and use subsetting using a logical vector. Okay, so let's save weight. So we have weight already saved within our environment, so we can easily call it directly. And let's say we want to subset it. Okay, and because we want a list, we put it within the list function, and say we want to see if I say true. Okay, so within R you can type true in full, or if you just type T, it automatically also recognizes that you're meaning true. So true or false, you can either type it true in full or false in full. Okay, so if I say weight true, so if I say true, so let's just run it and see what it gives us. And then I say false, true, and false. I wonder what that would give us. Let's see. So if I run that, it gives me 50 and 65. So on your top right, if you look at the value of weight underscore G, it has 50, 60, 65, and 82. And when we were subsetting here, we said true at position 1, false at position 2, true at position 3, and false at position 4. So it only returned for me the vectors or the values for which I mentioned true. So that's one way of subsetting using logical vectors, the true or false vectors. The other thing we can do is using conditions. Okay, you can combine multiple conditions into one argument, or let's start with one where we are only using one. So for example, I want to subset weight to see only the values that are above 50. So we say within that value underscore G, I only want to see anything that is above the value 50. So that is conditional formatting. Okay, we've given it a condition. We only want to see values within weight that are greater than 50. Okay, so let's run that. It gives me 3 values because within weight, we only have 3 values that are greater than 50, 60, 65, and 82. Let's say maybe we want to see values that are greater than 50, but less than 80. We can combine multiple tests using some internal functions within R. For example, weight, let's say we want to see within weight in G values that are greater than 50 and so this and symbol will tell R to look for values that meet both conditions. One, it's greater than 50 and and it is less than 80. Okay, so we've given it 2 conditions. One, it has to be greater than 50, and one single end symbol, its weight is less than 80. So it gives us two values. It's okay if you get an error. Okay, again, don't be afraid of errors. You can always just recheck your code, read the error, and correct your code. So and will tell R that it needs to fulfill both conditions, weight being greater than 50 and less than 80. The other thing you could do is say weight, okay, we want to look at weight that is greater than 50 or, so this pipe function, has everybody been able to type this? So the pipe function is on your keyboard, if you're using a Windows machine, is above the enter. On your keyboard above enter, you have that straight line, we call it a pipe, and a backward slash. Okay, if you're having any challenges looking at it, maybe one of the helpers can assist, but I hope we're all able to see it. So that pipe function, this one, to R it means or. Okay, in R it means or. So we want to subset weight to weight that is above 50 or weight that is equals to 50. Okay, so let's run that. So in short, we've just listed everything. Why? Because one, we've told it we want to list anything that is greater than 50. So greater than 50, we have 3 values, 60, 65 and 82, as we had seen here. Or the weight is equal, exactly equal to 50. So the double equal sign is read by R as being an exact match. Okay, you're telling R we want a value that is an exact match of our condition, which is 50. So that's why we have all of them. Okay, any questions up to there?
Bernice, I lost you with the piping.
With the piping, okay.
Yeah,
Were you able to find the pipe, number one?
I found it.
Okay, so pipe means or. Okay, so within R, this symbol here, that the and means it's actually and, just the way I've said it, and then the symbol pipe means or. So what we are telling R in this line is we want to subset weight, okay, to look at the values that are greater than 50 or exactly equal to 50, an exact match of 50. Okay, so that's why we have listed all our values. When we get the answer, we get the answer, all the values above 50, we have 60, 65, and 82. And we have all the values that are exactly equal to 50, which is 50, as we have in our answer done at the console. All right, is that okay?
Yes, thank you. Thank you.
Okay. All right. So what we're going to maybe quickly look at as we wind up is to look at missing data. Okay. So R was designed to analyze data sets, and because of course it was designed to analyze data sets, it has within it the ability to recognize missing data points, because you might be collecting data and some plots or genotypes or some whatever it is you're looking at might not be able to have a value, or you have data that is missing. Okay, so when you're doing operations, missing data points in R are represented as NA, okay, capital N and capital A. And most functions will return an NA if the data you're working with includes a missing value. Okay, so it makes it hard sometimes to overlook the cases where you are dealing with missing data. But you can tell R that your missing data points is equals to true, and it can calculate the rest of the data as missing values, as if missing values were removed. So for example, let's look at it. So let's say, for example, we create a variable called heights, okay? And within it, we store several values, 2, 4, 4. Let's also store NA and 6, okay? So we have a variable or an object called heights, and it has those values in it. So let me say I want to try and calculate mean, the mean of the values within the variable heights. It gives me NA. Why does it give me NA? Because as we said before, R will sometimes try to coerce values within a variable into one shared. So here, because we have an NA and we have not instructed R how to deal with NAs, it gives us a mean of NA, because you can't calculate any statistic with a missing value. But what if we say we want to calculate the mean of height And we instruct that NA values. So NA, and we can see when I type that, you see a logical value indicating whether NA values should be stripped before the computation proceeds. So we want to tell R that yes, I have NA values in my data, and this is set to true. So please ignore them while computing my data set. Let's try and run this. So now you see we have an answer. So R has functions inbuilt within it to be able to tell you or to be able to understand what NA values are, so that they are missing data points. Okay. So do we have any questions up to there? Okay.
So far, there's no questions in the chat.
All right.
Yeah.
Okay.
I don't know, we do the challenge for 5 minutes because I've already pasted the questions on
Okay.
HackMD. I don't know what's the plan, or you have something to add
No,
on your session.
we can absolutely do the challenge.
Okay.
Yes. We can absolutely do the challenge.
Yes, so there are 3 questions at the HackMD. If you move down at the HackMD, line 163, missing data challenge. So there's question 1, question 2, and question 3. And we can type in our answers from 176. That's okay? Yeah, and then we can take a break at around 11:45, a 15 minutes break, and then we can start up the lesson 3. Oh, okay. We were supposed to start at 11:45.
11:45, yes. I was going to say
So,
we've run over time. I was going to say that we've run a bit over time.
yeah.
Yes.
So, yeah, how about we start at 11:50? So we can combine the, yeah?
Yeah, Jennifer is already online. So
Mm-hmm.
yeah, we can consult with her if it's okay to start at 11:50. Hi, Jennifer.
Hi, that's fine. So we're saying 11:15. Sorry, I was reading something else.
11:50.
11:50, right?
Yes.
All right, that sounds good.
Okay.
Okay, so let's do the challenge, take a break within the 7 minutes, and then we can resume at 11:50. Thanks.
Okay. So if there's anyone who's been able to do the challenge, please go ahead and let us know the answer or show us how it's done.
Yes, and also at this point, I'm going to make some breakout rooms. So Paris, I'm going to take you with Kiragu so that you can be assisted. And then Ronald, I'll also go with you in a breakout session. So if you have any concerns, please let us know so that we can use this time to assist.
Yes.
So David and Paris. Irene, the challenge is in the HackMD document. So let me take Ronald to, with whom? Let me check. Ronald, I'm assigning you, who? Margaret. Group 2, Ronald. There you go. Or there's someone who has cut pasted the, let me redo it. Okay, thanks, Festus. Let me do that again. Please copy paste. Don't cut paste. There you
Oh, they
go.
removed the challenge. They removed the challenge? Okay.
Yeah, I think,
So what I can do, I can actually share my screen to that so that everyone can see it. Let me.
okay, that's good.
So there is the challenge on the screen. So anyone who's found the answer can post it on the question and answer, and we can see it.
Yes, so we have an extra 5 minutes.
Mhm.
So we'll start at 11:50. Jennifer is already aware, so that we can also give time for the guys who are already in the breakout session. Oh, Elias. All right. Let me take you to a breakout room. Sorry, I did not see that. Let me assign you. Elias, where are you? Yeah, there you go. And I'm assigning you to Festus.
I can see
All right.
somebody already posted an answer. That's quite good. Very smart
So
way of
Elias
doing it.
just joined the breakout room with Festus. You guys have not joined. Awesome. Oh, there's someone who's already, awesome.
Yes.
Yeah.
Very good. So please post your answers there, and I will later on, after maybe you've all got a chance to contribute, I'll add the answers. I'll probably send this to Mike, the script that I was using with the answers, so that you can share together with the slides, so that Jennifer can take over at 11:50. So thank you everybody for tuning in. I hope you've learned quite a lot.
11:55.
50 or 55?
55. So
Okay.
that we give time for the breakout rooms.
Okay, sure.
Yeah.
All right. So thank you everybody. Yeah, I will see you again, or we'll meet again tomorrow morning. I'll take you through the morning session.
Bernice,
you.
thank you
Yes.
very much. It was really
Absolutely.
a fun session.
Absolutely.
Yeah.
My pleasure.
All right.
Thank you. So Mike, let me know if we need to meet during the day or after the session.
Yes, at about 1, you can join in.
So yeah, just let
end.
me know. I'll be
Okay,
online,
okay.
and just let me know when I need to come back on. Thanks.
So.
All right.
Oh, Frank. Okay, let me assign you. Please, if you need to get to a breakout room, just quickly say, so that okay, this has disappeared. Okay. Frank, I'm assigning you to a group. Yes, Susan, because you've not mentioned that you wanted to be assigned. All right, let me assign you to one of the groups, Susan and Frank. Sawa. Susan, let me start with Frank. Where are you, Frank? Margaret and Ronald, you have not joined group 2, room 2. Susan,
Mike,
you've not joined. Yes.
Mike,
Yes.
we joined and we finished. So
awesome.
yeah, so his issue, we are going to deal with it later.
Okay.
Yeah.
Sawa. So let me give you Frank again. Room 2. Let me assign Frank. So Frank is, what is his name? Frank, I really can't get your name. Is it Justo? Funny.
Justo, yeah.
Oh, that's the same. That's Frank, right?
No. I think Frank is a different person.
Yeah, I can't see his name here. Oh. Yeah, group 4. I had assigned you to group 4. Let me take Margaret there as well. Please quickly join group 4, Frank. You have 3 minutes. Margaret is already waiting in room 4. Yes, George, you can type the answer to the HackMD document on the answers section. Yeah, now I'm closing all the rooms. In 30 seconds, we should start. Hi, Jennifer. I think everyone is back. The main session.
Hello, everyone.
Hello.
So as we go forward today, just let me know if, for example, the RStudio font needs to be larger, or if you have any questions, or if you're having difficulty hearing, anything like that, please let me know. And I'm, by the way, Jennifer Shelton. I'm a senior bioinformatics programmer at the New York Genome Center. And mostly what I work in is somatic mutations. So it's mostly cancer research, although I've previously worked in plant biology and some ecological genomics projects. So it's good to meet all of you all. And another thing is that, I'm working on kind of a at-home setup. So my screen situation isn't as good as it could be. So it'll be difficult for me to monitor the chat as we're going. So if one of the helpers could notify me if there's a question, and just a final thought too, that we should be keeping this conversational and relaxed. So if you're an attendee or if you're a helper, feel free to jump in and make a comment. If there's, for example, a way that you prefer working in R or something you found helpful when you were learning. And just to be clear, Mike, do you know how long we're running today? Are we going to go to what would be 12:57 for me or 12:55?
Yeah, so so I think the session should go at around how many minutes? 70 minutes. Yeah.
Okay.
So our time should be around 1, because we extended 10 minutes. So 1:05, it's okay if we're done.
Okay, sounds good. All right. So, has everyone created a script to be recording their commands on?
Yes, it's there's somebody who is in charge of that. So there's the HackMD that is it's been updated. So
Great. So for most of this, we're going to be working on that script, and I'll let you know if there's something that we should just be typing in the console rather than keeping in the script, just so you have a record of it later. And if I say to write something in the console, but you think that you want to keep a record of it, you can always comment that line out. So I'll show you an example of that. So for the rest of the session, we're going to be starting with our data. So loading our data and exploring our data. So the learning objectives for this section are going to be able to load external data, which is typically going to be disseminated in the form of a comma-separated values file. So you can think of this like an Excel spreadsheet, but it's all text format. So the columns, instead of being separated by like an image of a bar, are separated by a delimiter, which in this case is a comma. It's often a comma, but you might want to use something different, like say a tab, if, for example, your data contained commas. But the most common one that you'll see is a CSV, comma separated values file. And we're going to describe what a data frame is, and we're going to summarize the contents of a data frame, and then we're going to extract subsections of that data frame. And then we're going to talk about things called factors and how to work with factors. Okay, so the data that we're going to be looking at today that you all have already downloaded includes information about species diversity and animal weights found within research plots. And we've created a directory called data raw. Has everyone done that? Because you did that to download your data, right?
Yes, everyone downloaded the data set
Right.
already. Yeah.
Okay, so you did that with the commands like dir.create to create the directories, and then download.file to download the data. And now we're going to install a package called tidyverse.
Jennifer.
Oh,
just
the
before I take
installation's
you
already
back,
done.
Yeah, the installation is already done.
Sorry
Maybe
about that.
setting directory, that is something that we didn't mention.
Okay.
Yeah.
Okay, so you can do set working directory. I don't know that we need to do that in this case though, because the commands that are for this section are actually written from the home directory of the base directory of this. But if you wanted to set a different working directory, what you would do is write set working directory. And then the argument that you pass within parentheses would be the directory that you want to use as your current working directory, which means that if you were to write a path out, you could start that path from that working directory. So if I wanted to load, so let's say I want to load the surveys data in data raw. So I'm actually not going to run this, so I'll put a little comment, a pound sign ahead of that so that nothing gets executed. So up here, I'm going to load my data, right? Can everyone see that? So I'm in the base directory of my project, and I'm going to load my data using read CSV, which is going to load it into something called a data frame that we'll talk about later. And the path to it from my base directory is to go into data raw and to find the file. So I can execute this by typing control return or command return, depending on whether you're on a Mac or a PC. But if I say, for example, did not want to have this prefix here, then I could set the working directory, move into that directory, and then rewrite my path to match that. Okay, so if I said, for example, set working directory data raw and hit enter. Now, if I tried to rerun the surveys commands, I get an error. And this is actually a good error to see because it's one of the most common errors that you run across when you're just starting out programming. It's also one of the most common errors that you run across 8 years, 9 years, 10 years into programming, is that there's an error in the path. So it's looking for the file, but it can't find the file, so it can't run the command that you want it to run. In this case, can anyone guess why it can't find this file anymore now that I've set the working directory to data raw? If anyone has a guess, even just a wild guess, you can throw it out in the chat.
My guess is that you don't have the file on data raw yet.
So I do have the file in data raw, but now I have changed my working directory to data raw. So what it's looking for now is a new directory within data raw called data raw, and then within that, the file.
Oh, yeah.
So this is what's called a relative path. It doesn't start at the base of my file system. And we don't need to get into too much detail about that, but I know that's true because it doesn't start with a slash. So slashes kind of separate the parent directory from the content within it, but any path that starts with a slash starts at the root of the file system. Otherwise, it's what's called a relative path, which is great because it's shorter to type out. But the downside of it is situations like this, where I can break it by changing the directory that I'm currently in. Okay, so if you ran that and you want to get surveys back, the way that you can do that is to correct this command. So in this case, we would correct it by removing the extra data raw. So now I'm just looking for portal data joined CSV, right? So I can hit enter on that, and now it loads. And what do I mean by saying it loads? It just means that the library read CSV has run the task of reading in this comma separated values file. And it tells me, it gives me kind of a breakdown of the columns that it's loaded. So I can see here in columns that I have one called record ID, which they're saying the type of that is double, or month, where the type of that is double, which is like a number that can include a punctuation point. Oh, sorry, punctuation that can include like a decimal space, decimals. I've got day, I've got year, I've got plot ID, I've got species ID. This is a different kind of column. It's a character column, which would include things like, you know, cow, horse, pig, like those aren't actually species, sorry. Homo sapiens, for example, is a species. And I've got the sex of the animal, hind foot length. Again, this is numeric column. Weight is a numeric column. And then genus, species, taxa. These are all character, and plot type. So the plot here is like a plot on the research location, on the research site. Okay. And read CSV is actually guessing these types for the different columns, and it's guessing them by looking through the first 1,000 rows of each column and guessing the data type. So, you know, this is very likely to work correctly. You could imagine a scenario where you had a corrupted file, for example, and maybe the last items in species were really meant to be numeric for some reason that you didn't intend. Or maybe the first 1,000 were numeric and the last column was character or something. So you still want to be careful about confirming that this type is correct. Although I think that would probably generate an error. All right, so let's try taking a look at this data. So there's multiple ways to go about something like that. And actually, if you haven't run this already in this session, at the top of this, you should run library tidyverse. So I'll put this at the top and then run command return or control return. Okay. So one way that we could take a look at this is using something like print. So here I could say, for example, I could call a print function and I could pass it in the parentheses the name of the data frame that I'm pointing it to. So in this case, it's surveys, which can be auto-completed for me. And if I run that line, then what I see is kind of like this little summary of my data frame. So up here, it tells me that what I'm looking at is what's called a tibble. We'll talk a little bit more about what that is. I can also see the columns printed out at the top. And I can see the type of the column, like whether they're double or whether they're a character printed up at the top. And then I can see like a little peek into the data. So I see the first 10 lines here. And then at the bottom, I see a note just to let me know there's actually a lot more data than this. There's 34,000 more rows and 8 more variables, so 8 more columns. So in this case, each column represents a variable and each row represents an observation. And that's the way that you always want to organize your data.
Jennifer?
Yeah.
So some of the attendees are a bit lost. Maybe if we can confirm if everyone has loaded the data and saved it in the variable survey.
If everyone's loaded tidyverse?
No, I mean in the second line for the survey, if they've already loaded the data as a variable survey.
Sure. So these need to be followed in order, in order for the final thing to work. So everyone should try this. And if you get an error from this, then add the directory name to the front of it. It may just be that you haven't set the working directory to the raw data.
Rispa, you were saying something?
No, I'm just saying that I'm really lost. I really don't know how to do that survey. Should I copy exactly what she is showing here, or I follow where my data is? Because I think that's where I'm getting lost.
Okay, so here, let me go back to set working directory, and I'm going to say set working directory 1 up from the current. Okay, so now I'm back in the home directory. So if anyone changed their working directory, you can run this, and that will move you back up to the original directory. So I can say raw data / now, and then I can like say highlight these 2 rows to make sure that these are running, and then type control enter to run these. Data. Oh, is it data raw? There we go. So can everyone indicate if they've successfully loaded that and this is what they see? And if you're seeing something different, could you let me know what it is that you're seeing, and then we could work through it together?
Yeah, Jennifer, I think yeah, Grace has successfully loaded.
So Irene, what is it that you're seeing when you look at your screen? What message are you getting?
Maybe just to confirm, I can see that on your console that your file is named portal data joined, and ours is combined. Is it the same document you're talking about?
Oh, so I was following the instructions on the lessons that I got. Do you know, is it possible that I have a different file, Mike?
No, I don't think so. So I think when you click on the download, it is saved differently.
Yeah.
Okay.
It comes as combined.csv.
Yes, there's one way of doing it. Maybe you can rename the document to now portal data joined and then .csv, Or another way is now every now and then when you see portal data joint.csv, you write yours as combined.csv. I think that would
Okay,
work.
so it's the same file. That's just what I
Yeah.
wanted to confirm. Okay.
Okay, so if I'm wondering what files I have available in a situation like that, I can list the files that are available in a directory. I don't have to say, for example, go to my Finder and find that on my file system and look at, in the Finder for the content of it. So from within R, we can tell it to, hey, list the files in this directory, list the files at this path. And that's a good way for us to check to see what our data is named. Yes, and I hear you that the typing and following at the same time is a bit challenging, but it also keeps you engaged. And we can kind of use opportunities where there's an issue to try to work through what's going on and kind of enhance people's understanding of what it is that's happening. Sometimes if you are like passively sitting through a lecture like this, then you can feel as though you've followed the content and then walk away with real questions, like when you get to a very common situation like this where you get a path error. So it's kind of good to work through and try to type along with us. And we'll try to move slowly, so please, like this, in this situation, let us know if there's something that you've got a question about. Okay, so I'm just going to put a commented outline here. So what some people are seeing, correct me if I'm wrong, is combined.csv rather than portal data joined. Is that correct? Read.csv is different from read_CSV. So in this case, we should be loading the library tidyverse and then using read_CSV. One of the differences between underscore and .csv is whether or not it's loading something called a tibble, which is a special kind of data frame. We're not going to talk a lot about the differences between a tibble and a what's called a base R, or like just a R without loading any libraries data frame. But it has a lot of extra rules, which can cause it to give you lots of errors, which sounds annoying until you've written, like 50 lines of code and some small part of it doesn't work. You're going to be very grateful for having a lot of those rules. They become kind of like bumpers on the side of the road, to help protect you and keep you in your lane, to help, constrain your code so that it's less fragile and less likely to break.
Jennifer, about the line 2, I think guys are getting difficulty loading the data. It's because maybe in their mind, so the data, most of the guys have pasted it in the document, in the desktop. So probably maybe they can, you can show them how to, direct the path to desktop and then get the file. Or if they've saved it in a document section, then they can go to document, because most of them are working on Linux.
Right.
Windows. Yeah.
So if you wanted to list the files on your desktop, for example, then you may try something like this. This is probably going to be a long list for me. But so this symbol here is called a tilde, and it represents your home directory. And then this is the file within that. That's usually what your desktop is called. So if you list these files, then you may see the one you're looking for. And you could try to say, for example, search for this specific file, you know, I could try to list this rather than seeing all the files on there and just see if I get an error or not, see if the file exists. Okay, so that didn't return anything, so I could try combined. And that's not returning anything. But for you, if your file is downloaded to your desktop, that may return something. And you could do the same thing for your downloads directory. So right now we're using a relative path that starts in our current working directory, but this ~/ is very helpful for searching, for example, your desktop or your downloads folder. Those are generally held in your home directory. I say generally, but they're pretty much always going to be in your home directory on every, you know, PC, Mac, laptop, standalone computer. Right. So I see someone saying that the error that they get is that this does not exist. And so what I would say to you, George, is this is like a super normal path error. And the first step that I would do if I see an error like this would be to say, okay, well, if that's not in data raw, then what is in data raw? So I would list the files. And in your case, data raw is, it looks like it's spelled like this. And I would also check to see if data raw is really spelled the way that you think it is, right? So you could say list files in here. You could also say like list files in this for the current directory. So if I run something like this, it's going to show me the files in my project directory. So this can help me figure out things like, is my directory really called data raw capital D, or is it data raw lowercase d? And there's also tab autocomplete, which is very helpful for path errors. So if I start from my current working directory, like this dot, I could say /, and then I could start typing the path as I think it exists. So I may say DA and then hit tab, and it will try to autocomplete that for me, but it'll show me every option that exists in the path downstream from where I am. So my two options now are data and data raw. Now data raw is the one I'm interested in. And then at this point, I've only got one file in there, but it doesn't look like it's gonna tab autocomplete from there. Maybe because I'm trying to list files and this isn't a directory, but no, that should work. Okay, so George, when you try to list data raw or list files within the directory data raw, can you see data raw as an option?
Yeah, it is an option, but now the problem is that there is where I can't get the files that I saved yesterday.
So if you run a command like this, but for your spelling of data raw, what do you see as output?
The file that I created today that we were working during the first session.
And nothing else.
And nothing else.
then that means that you probably downloaded it to, say, your downloads directory or your desktop directory. So I would try listing the files on your downloads or your desktop. So I gave examples of how to do that kind of thing up here. And actually, I think for list files, it's only going to want to take the argument of a directory. So if I were you, I would try something like this. Now I'm not going to run this because I have a lot on my desktop right now. So it'll kind of fill up the screen, but I would try something like this, or the same thing for downloads. Should be like, so do those show you either of the data sets?
I'm still giving the command.
So while we're doing this, yeah, I just definitely want to reiterate that the two kind of main bugs that you'll find in coding are going to be path errors. I'd say that's about the most common, where a program is looking for a file, either like a file that has code in it or an input data file, or an output directory to write into, and it can't follow that path because it doesn't exist. That usually just means there's a typo in it, or you need to make the directory, or you're using a relative path and you are currently not in the directory that you think you are in. Like earlier when we set our working directory as data raw, and then we couldn't use the relative path that we were using from the base of our project directory. And then the second most common error would just be that you have a typo in your code. So earlier we were talking about read_CSV versus read.CSV. It's not exactly a typo, but for the exercises we're doing, that difference between the underscore and the dot means the difference between what kind of behavior you're going to get out of the program, and would feel like a bug as we were moving forward. Yeah, Git working directory is great because that can help you find yourself in the file system. So Git working, Git WD like this will show me where I am on my file system. And that way also, I use commands like that sometimes to be able to write out what's called an absolute path. Like I said, that's a path that starts with this slash. Any path that starts with the slash is an absolute path, and that path will work wherever you are on the file system. So I can change my working directory and the path will still work if it starts with that slash. And that can help you figure out the kind of path error where you aren't where you think you are and you're using a relative path. All right, George, do we have any update on how it's going in finding your input? Or not just George, does anyone have any update? Is anyone seeing any new errors? Because I think this conversation is pretty fruitful for figuring out how to navigate the file system and how to load your data.
On my side, I'm okay. I'm up to par with you.
Okay. Is anyone else having an issue, or is anyone else working to load their data? Please let us know if you are, because it can be very useful for other people to see, you know, if you're having the question, probably someone else is too. Right, Cynthia, so list files, downloads, character 0 means that you don't have any files in your downloads, I think. So for example, I have lots of files in my downloads. So that just means that there's no files there. So I would maybe check the desktop. And then I would maybe circle back to like, did the file get downloaded if it's not on desktop? And so this would be what the desktop command would look like. Does one of the helpers want to share the commands to download? If anyone needs to re-download?
Yeah, it's already shared in the chat. Let me resend again.
Can you copy and paste out of the chat?
Yeah.
Does Slack let you do that? Okay.
Okay.
Let me try.
First, as you've done that before, just quickly paste it. So
yeah, let me do that. Yeah. So Cynthia, if you can't find it in desktop and you can't find it, then you can re-download it and then find the path probably in downloads or on desktop. Okay, so does anyone not have the data loaded? Still having an issue. Okay, can you let me know, Sylvia, what the issue is that you're looking at? And by what is the issue? What I mean is like what error messages or what messages are you seeing from R?
Okay, so thank you. I'm trying to establish the path to which I can actually get the data from. So I'm getting, after putting in the command, I'm getting the character 0. So I'm just trying to find where the file is at.
Right, and so you're getting character 0 after you try list files desktop?
Yes, yes.
And after you try list files downloads?
Downloads, yes. And I've saved it. I can see it on the desktop, but I don't know why it's not being accessed.
So you can see it on the desktop?
Yes, I can. And I'm trying to see if there's any typo or maybe case sensitivity, but I can still get it. Sorry?
Let her paste it on the chat so that we can see the code that she wrote.
Yeah.
Okay.
But
okay.
I also think the path in the Windows machine is different from the Linux or MacBook. So I think probably that's the issue, because the path for Windows usually uses the backslashes, while for the Linux uses the forward slashes. So I think that could be also an issue.
Yeah, I hear you. I think that typically the path to desktop is the same, in that in Windows, when you're using R, the / should work. Can I get confirmation on that from anyone who's successfully using Windows?
So the default working directory for Windows most of the time is always documents. So one of the things that I would suggest is maybe those who have saved the downloads to save it in their documents option, and then they try and see how that will go.
But I have a slightly different question. On when you're using R on a Windows machine, do you have to use the backslash, like the name of the disk, and then backslash rather than / when you're creating paths, or can you use / and it'll interpret it correctly?
So most of the time, let me try it, and then
is it forward or back?
Yeah. If someone with a Windows machine who's comfortable with R could just list the contents of their backslash is
fine.
Right, but is it necessary? That's the question, because it's easier if we can all use the same thing.
Not really. It works just fine the way you've typed it here.
This one.
Yeah.
Yeah.
Yes.
Okay. I can also try this. So that'll show me, say, for example, what directories I have. So here I can see that I have a directory called desktop. Okay, so just to recap, to explore my file system, I've done something like this. And something like this. And when you type this, don't put the pound in front of it, because the pound will make it not run. I'm just putting it there so that you all can see it without it actually running and kind of going away, scrolling off the screen. So you want to type what I just typed, but without this pound sign. Yeah, so here in the chat, there's an example of what a path really looks like on a Windows machine. So you'll see it's like, it's in C, the C hard drive, and then //. That first one would indicate like sort of the root of that file system. And then, you know, you've got users, the username, downloads, and then the location of it. So that should work. But I think also just // downloads should work as well. So Kevin, could you try something for me to see if it works? Could you try? Could you try running this and see if you get output, running that without the pound sign in front of it? Yeah, you can also copy and paste.
Can the issue be that the guys who are having trouble, in the first session we created folders and we were working within those folders, so maybe they didn't go back?
That shouldn't be the issue because we're starting this with /, which should, it's a relative path, but it really starts at the root directory and then goes up to your home directory. So there could be the issue for some of them that can't find it in data raw. But we tried to solve that earlier by saying set working directory ... So to set the working directory as one directory up.
So, Jennifer, I think they can just load the data using the import data set, and then they can just copy that path and then pass it to the read CSV.
So someone wanted to load the import data set commands into the window, and then anyone who's still having an issue with a path can use that command into the chat.
On the top left, I think, of the RStudio, there is file, and then find the import dataset, and then that will give you more of a graphical show of your directories. You'll find the file, and then once you click load it, on the console, it will give you the path, and then you can use that path now to read the CSV.
And I don't think I can show you that because I think it'll only show you my screen right now. But yeah, that following that up to file and then load will get you there.
Yeah, that one. So they can just, from text, base or read R, and then they can just use the path they get once they load the data set. So from text, if you click there, they should be able to now search for, in the Windows, they should be able to find the exact location of where they.
Yeah.
So if you click on browse there at the end of it, so. No.
Oh, browse.
Yeah, they should be browse. So if you remove that one, you should browse. Yeah.
Yeah.
So they can be able to find the exact where their data is, and then they can now open
Yeah.
And then
So this is showing me my path. And you notice the path starts with like / data carpentry because data carpentry for me is in the home directory. That / just means my home directory.
Yeah, I think that was a good idea. And then you can finish by import. Then I noticed that you have already a command comes in on your R.
Yeah.
so
You could also just copy the path out of this, I think, and then use whatever commands you wanted to. So if I copy that and hit cancel, then I think I can make my surveys commands. So I could say surveys, use the assignment operator, call read _ CSV, and pass in the path.
Yeah.
Okay, so then that successfully loaded the data. So if anyone is still having an issue loading the data, maybe could we get a breakout session for that person, or can I get an idea of how many people are having? Right, okay, so I think to the most recent questions, we're going to follow this searching for it through RStudio route, where we go to import data set from the file drop-down menu. And we go from text, does base or read R matter?
Base is fine.
Yeah, from text base. So Irene, are you trying the import data set from the file drop-down menu?
Irene, please speak up, or you can type the error.
So I think if we're using the from text base option, loading there's no cancel. Oh, after loading there's no cancel option. So there's only the import option?
Yeah, if you, let them
I think that's
import.
fine. If I, if I hit import, it just opens this.
Yeah.
But it'll still give me a chance to see the path to the data and copy it.
But it's actually the second last code in the console. So it automatically saves it as portal data join. No, the other one.
This.
Exactly. Yeah.
Yeah. And so we don't want this because this is like read.csv in base R. So this isn't what we want, but it does show us what the path is.
Yeah.
Right. So then we can construct the path that we want from this. So I could say, I'm just going to make this more readable by saying like file, and then I'm going to assign that to this. Now I can say surveys is read _ CSV, which is like the important difference file. And then if I execute that, I see the same thing that I've been seeing when it successfully executes. So we were really just using this file import data set as a shortcut to help everybody find their downloaded file. Okay. So you can go ahead and hit the import button if you don't see a cancel option. That's totally fine. So has everyone loaded an object called surveys now? Does anyone want to let me know if they have successfully loaded the data or if they still have a question about loading the data? Oh, what you do after you get the path is you run your read_CSV command. So you can either write that out like you see on line 5 here, where you say surveys, and then you assign that the value of running read_CSV on the path to the data. Or you could do what I did here just to make it a little bit more readable. You could assign the path of the data to the variable name file, and then write like surveys read_CSV file. So you want to run something like this, or like line 5, once you get the path.
There's only one yes from Cedric.
For successfully loading?
Yeah, Hendrik also mentioned.
Okay.
So with
as
others,
people,
should we do a quick breakout room?
Yeah, I think that would be good.
All right. So yeah, how many?
Sounds like a lot are coming in successfully loaded.
So we just wait.
Yeah. And
okay.
George, is it possible that your downloaded data has gotten corrupted somehow? That maybe if you re-download, then that would fix your issue?
Frank, Ronald, Harriet.
I mean,
yes.
no, because I can able to see the data.
Right, you can see it. The path
after importation, I can able to see the data. But now, when I tried to view it, to read, to give the command to read, but I get that error.
Read_CSV is when you get the error.
Yeah.
Okay, so what's happening is the path works, but the data isn't loading, which makes me think, is it possible that the file has been altered since it's been downloaded? Which is why I say it's a small data set, so you may want to re-download and then import it again.
Okay.
And probably delete the file that you downloaded last time so you don't end up with a funny file name like adding _1 in it, to indicate this is not the very first download.
All right.
And Irene, what is the issue that you're seeing? Oh, okay. Great. Yeah. So this issue, the path error, finding something on your file system, is definitely one of the, like I said, most common errors that you're going to see. And it's probably one of the biggest differences between working in the GUI, graphical interface world, and the command line interface world with something like R. And in RStudio, we're a little bit lucky because we can still go to a graphical user interface kind of thing when we go to, like, say, for example, file, import data set. So that can help kind of bridge that difference. But it's still, I think, exploring your file system with things like check working directory, set working directory, list files, That kind of stuff can be very useful. Understanding how to use // to list the contents of your home directory can be very useful. All right, great. I see a lot of successful loads. Is anyone still having an issue? Or have we moved to breakout rooms for everyone who's having an issue?
No, you just said we wait.
Okay.
Because I think Irene still has some issues, so maybe, all right, Irene, Sylvia, maybe I can take them to a breakout room.
Great.
All right, let me do that.
Okay.
So.
And we'll just get started gingerly on a couple things, and then when you all rejoin. Does that sound good? Or would you like to wait?
How many minutes? We do 10 minutes? 5?
Sure.
How many?
We're planning on ending the session, I think, a little bit after that, right?
Yeah.
So why don't you do the breakout session and we'll just discuss data frames a little bit. And then we can get into data frames more in the morning. I think it's good to establish, how to load the data set very clearly, obviously, for the rest of the exercises.
Yeah, and I think the other things would be easy to follow.
Yeah, yeah.
So 10 minutes is fine?
Yeah, 10 minutes, and the rest of us will just discuss data frames, but we won't do very much coding, so that when you come back, we'll be starting all together.
Okay, so let me.
And George would like to go to the breakout session.
All right, now I'm just assigning, just give me like 1 minute so that I don't miss anyone. So Sylvia, Irene, I'm assigning you to group 1 with
So for everyone else, does anyone have a question about anything we've done so far? About directories, about paths, about things like absolute paths, relative paths, anything like that? Or read CSV? Or does anyone have a question about the difference between read.csv and read_CSV?
Maybe just as a refresher, it would be nice to know the difference between the absolute and relative parts, and whether they both work with read.csv or the read_CSV.
Right. Yeah. So paths are something that are kind of orthogonal. Like you can write it the same way in lots of different arguments to lots of different commands. You can write it the same way in R as you would write it in Python, as you would write it in Linux. And relative paths, also orthogonal, like the structure of it is almost always the same. So that they're really good to learn because whatever you're working in, you're going to see the same kind of paths. And earlier when we were talking about Windows versus Mac or Linux environment, yeah, there is a little bit of a difference there. But when you're working on Python or R, typically you still write it the same way, whether or not you're on a Windows machine. So for example, let's write an absolute path. So when I ran this command, get working directory, that returns to me an absolute path, right? And so this shows the path to my home directory, and then from my home directory, the path to the directory that I'm currently in, and that's data carpentry. So if I wanted to say, for example, list files, then I see the contents of my current working directory, which is data carpentry. So if I wanted to make, say, an absolute path to my code handout, then I could say, I'm just going to name this code handout. And I could set that to be my current working directory plus the path to code handout. Okay. So that's created something that is an absolute path. And I know that because it starts with a slash, which means it starts at the base directory. And a relative path could look similar, could be something like this. Okay. So this is a relative path that should work the same way, provided that I stay in the data carpentry directory. Now, if I move to a different directory, say like I set working directory to some other directory, then I can break this path, because now it's not, when it looks for a file, when any command I'm trying to run looks for the file, it'll check my current working directory and it won't see code handout there. And it, you know, unless I have a second file that's also named code handout that just happens to be in my new current working directory, I'll get a path error when I try to run something like this. Another version of a relative path would look like this. So I could say // data carpentry /. Okay, so each of these commands are all saying the same thing. So the first one is showing it with an absolute path, and I know that's because it starts with a slash. The second one is showing it with a relative path relative to my current working directory. And I know that because it doesn't start with anything, it just goes straight into the path. And this one is also a relative path, but it starts relative to my current working directory. I just need to go and get a power cord quickly, but one of the real uses for something like // is in a situation like this, where I may be sharing commands with other scientists. So one thing I can be pretty sure of is that everyone's home directory is going to have a different path, right? So like my home directory is literally like named after me. Oftentimes your home directory will be named after you or the user that you are currently logged in as. So since I know that everyone's home directory is going to be different, I can still write instructions that allow people to follow them like simply by copying and pasting, essentially, if I use /. So I can tell everyone, you know, create a directory called data carpentry and put it in your home directory. And then I can give you exact commands. Once you've done that, I can give you exact commands to follow that will be executable using // rather than having to say, you know, fill in your home directory path here, right? So that's very what you would call portable and shareable, which is great for a situation like this. Another thing that you see a lot in code is dot or dot. So let me just go back to this. So dot means my current working directory. So if I try to say this is actually the exact same thing as this. In fact, all of these will produce the same result. All of these are pointing to the same file. How I would read this, if I was going to like read it aloud to myself, is I would say, in my current working directory, my current working directory is dot. There's a file called code handout, right? I could also use dot to represent going up one level. So if I go here, I could say dot and then come down into data dash carpentry. So does anyone have any questions about these options? Like, are these variations on the same thing?
It's very clear for me now. Thank you.
Jennifer, should I end the breakout sessions?
Yeah, if we think everyone has the data loaded.
Yeah, I think room 1, guys have done. It's only room 2 and 3.
Okay.
Can I jump quickly to room 2 and find out?
Yes, that would be great.
Okay.
Okay, and this is a really handy thing to know about too. So let's say I'm writing my code and I want it to run on its own when I'm not there. I may want to add some tests because like I said, path errors are very common. And oftentimes people will be adding, passing to my commands or passing to my program paths. So they'll say like, you know, I want you to run this analysis workflow and I want you to run it on this input file, but your input file may change, you know, week to week. So one thing you may do in your scripts is after you get the name of the file, you may want to test it to see that it exists, right? So I'm going to put these up here so I can show you kind of how that would look. So let's just say, I have to get rid of these prompts here. But then after each one of these, I could test that it exists. So down here, I can see that they're all returning true, right? So I get a Boolean after it executes each one, because each one of these is a real way to write this path. They just all look different. And I would use them all in different scenarios. So this one, for example, the .. for the parent directory, and then, you know, you can come back down to something, or this one for the current working directory, whatever current working directory I'm working in. You will see these oftentimes in code packages that someone writes and distributes. So for example, in this workshop, we may have like a, you know, / data carpentry scripts directory. If one of my scripts was referring to another script, it would start with / because it may know that, you know, you may share the scripts directory with someone else, and I don't know anything about their file system, but I know that the code I'm looking for should be in the same directory, the same scripts directory after you shared it with them. The same thing with this parent directory. You often see that in directories full of code that have been created and are intended to be distributed and run together. / you see in situations that like the workshop we're in right now. So you see that in software tutorials and in workshop kind of scenarios. And this one, the relative path that just starts in the current working directory, a lot of times people use that to shorten their typing. And this absolute path, a lot of times people use because they may be wanting to change directories frequently and they don't want their command to break. That's one thing. Another thing that I use absolute paths for a lot is if I'm, say, starting up a pipeline and I want to refer to my reference files. And one of the reasons I write my reference files in absolute paths is because then it doesn't matter where I am on the file system, and I don't need to know kind of like multiple pieces of information to figure out what the path is. You know, like were there any previous commands where I changed a directory or set a directory? And that allows me to do things like test that a file exists without having to kind of like cobble together what the path is. So when I say like test that the file exists, it may seem like kind of a minor point, but literally, like if I want to run something on Google Cloud, the kind of way that we run that at the Genome Center or at the Broad, you know, when we're starting these huge pipelines, that doesn't naturally check to see that all the files exist before it starts all these instances. So you can actually, you know, get time on a cluster, get time on the cloud, start these big machines up running for tons of samples, and then it all fails because, you know, your reference genome file doesn't exist or the path is wrong. So it's good practice for things like reference files to be able to you know, store an absolute path somewhere so you can quickly test, you know, just once for each of those. All right, those all exist before you start using them in your code. And to use things like file exists before a program launches. Otherwise, the program starts running and it may be a while before it needs that file. So you kind of waste compute time and then find yourself back to square one. Or find yourself back to the beginning.
Jennifer?
Yes.
So there are two attendees who are being attended to.
Okay.
In the remaining, so there's one breakout room that is still going on. Okay.
So I think I'm going to share just instructions to start, starting with the data for next morning. And we're still, I think we should still and can still get to visualizing by the evening. Maybe we'll talk together about like how we'll structure it. But I don't think that we really have time in the next couple minutes to get too far into data frames.
Okay.
And I'd like everyone to be here for that discussion. So in the final few minutes, does anyone have any other questions? Because that question about paths and relative paths was great. I'd also like to say that everyone's doing a really great job of asking questions and explaining what error messages they're seeing. There's an expression in programming that no news is good news. So like if something runs and doesn't give you a message back, it generally means that it ran okay. But you can also have a situation where a program didn't do what you wanted to do and you don't see an error message. And that is the worst scenario to be in. So when R gives you an error message, that's great because it's information that you can read, you know, and try to figure out what's happening. So you could say, for example, like, is it a path error? Well, can file exist? Does that work? Or does the error suggest that the path does not exist? Yeah, no problem, Harriet. So maybe I could talk for a second, if no one has any different questions, about the difference between the read.csv and read_CSV. So we were loading a package at the very start of this called Tidyverse. Tidyverse actually creates something called tibbles, which, like I said, are similar to data frames, which are, you know, sort of chunks of data where you have columns representing different variables and each row representing different observations. So each column has to be the same data type. Each column is like a vector. And data frames have existed in R since like R has existed. But the early versions of them were kind of hard to work with. So Tidyverse is a new, has a new object called like a tibble, which is basically just a data frame with some extra rules and also extra features, which is very nice. And they those extra rules can give you more error messages when you're writing it, which can feel like, why would I want something that gives me more error messages? But the benefit of that is that it's more difficult to write code that is fragile or will break. So when we use read_CSV, the results are just slightly different from read.csv because they're coming from tidyverse, which is giving us that nice Tibble version of a data frame rather than what's called the base R version of a data frame. And when I say base R, I just mean R that you just get from installing R. You don't have to run install packages to load some kind of specialized library. It's just the standard stuff that everyone gets whenever they load R. And base R is nice because it's portable. You know, sometimes it's difficult for people to load libraries, but the downsides are, like I said, that there were actually some kind of very difficult to work with aspects of the old data frames that in data science we're really trying to avoid, you know, so you don't end up with code that is accidentally buggy, you know, or running in ways that you didn't expect it to be running, because that can, you know, that can introduce flaws in your data analysis. So that's why we're using read_CSV rather than read.csv. And that's when you hear someone say base R versus, you know, some maybe software that you get from another scientist that has a section in the installation instructions called dependencies. So like the software won't run without, it depends on these other libraries that are not in base R, like for example, tidyverse. Okay, so I think that actually brings us to the end of our time today. So it was great meeting everybody, and I will see you again tomorrow, where we're going to go over some plotting, and we're going to get into working with our data frame. Is there anything that anyone would like to add? Like Mike, do you have any parting words? Or
Yeah, that's what I wanted to ask. So should we start our session, say 30 minutes earlier, so that we can cover what we're missing? Because I understand that would have 30 minutes. Like if we start 9 our time, then 30 minutes to just do a refresher of day 1.
Yeah, I'm not starting on day 2. So we'd have to check with the instructor, but I think that makes sense. We could also go a little bit longer. So either way.
So we start with this session because they have to connect with the data manipulation.
Yeah.
Yeah. So we start with this and then we can tell Bernice to start at 10.
Yeah. If that's fine with Bernice, that's fine with me.
Then we can.
So when you say we, do you mean that I would come back at 9:30?
Yeah, because now we need to do this before we get to Bernice. Yeah.
Time-wise, that might not be.
How about we do this? We can discuss this.
We can discuss it offline, and but for the participants, we'll start a half hour early tomorrow.
Okay, I think everybody is back.
All right. So we were just letting everyone know that we're going to start a half hour early tomorrow.
Is that fine for everyone? 8:30 tomorrow?
Great.
Awesome. Yeah, I think everyone is saying that's fine. Cool. Then yeah, Festus, you want to say something before we end the meeting?
Yeah, I think it has been a good session despite the few challenges we have running through. But I think right now, where we are, I think everybody's at par. So I'd like to thank everybody for taking their time to join in, and especially to our instructors for taking their time to go through the whole process. And I'd like to appreciate the participants also for being keen and to learn. So I hope by tomorrow everything will be okay. So
yeah, and thanks for the great questions.
yeah, so maybe I think we can just have a group photo, Mike, yeah? Or there's anything else which I was in the breakout room, so I'm not sure I have everything, all the
Yeah,
info.
sure. This is the time where we need to see faces and take a photo for a successful day one.
Yeah, so for tomorrow, I think we'll start up early. So we'll pick up from where we are stopping today. So we'll have to start up early to cover up the sessions which are remaining today. Yeah, Jennifer, that
Yeah,
will be
that
okay
sounds
with
good.
you? Okay, awesome. So any other concerns, Mike? Okay, so I think if there are no other concerns, I'd like Jennifer, kindly you can stop sharing the screen. So I'd like the participants to turn on their videos. I think it's a good time. I see all the participants for group photo. Okay, so I can see people turning up their faces.
Nice to meet everyone.
Yeah. Okay, so people are coming up. Okay. Let me just give a few, I think a few, 2-3 people haven't still turned on. So, okay, awesome. So it's time to say cheers. Put on your best smile. Cheers. All right, so are you ready for the group photo? Okay, awesome. Awesome, awesome. All right, thank you all. Thank you.
Thank you, bye.
Bye. So I think, Mike, I'll leave it to you to just conclude the meeting.
Yeah, so let all the instructors and helper just wait a bit for 10 minutes.
Yeah.
And yeah, the other attendees now you're free to leave. Thank you for your time.
And remember, you can reach us via Slack channel if you have any challenges or issues, or just paste your questions on the RKMD document. We'll just be doing roundup on the same.
Let me try to move further. Participants really quickly.
So I think people have had challenges loading the data sets.
Yeah, I think so. We had the session to install data, but I think that maybe even without explaining why we're doing something, we should maybe try to get them to check that the file exists in a particular location, so that we can get people to copy things over, you know, in that first section where they're downloading, and because I think that would like speed up.
Yeah, I think let's start with what went well. Our successes first.
Oh yeah. No, I'm sorry. I think I was thinking because they already downloaded the data, I wasn't expecting that that we would bump into things, which is silly because there's always something, right? Especially with new content, you know. So I should have caught that earlier, that there was more than just the different file names going on. But I actually thought a discussion of what paths are was probably very useful for people who are getting used to command line interface.
Yeah, I think we took so much time in trying to, install the R Studio and R and even the packages. Yeah.
Yeah,
So
it is,
like a
installation
meeting,
is a bear.
yeah. So like in a meeting, we took like 2 hours.
Yeah.
Yeah. So you can imagine. So I think,
Yeah.
yes, you're right. I think maybe moving forward, we need to consider also like making sure that they have also loaded the data in their R in as
Yeah.
much as they have downloaded it.
It might even make sense to make this a section, like to maybe pad in a little extra time and make a section where you're talking about paths, and each of the exercises is kind of meant to like make sure that the path exists before you start loading it. Because it's useful to know about paths, and if like installation is like perpetually difficult, for things like this. So everyone has a different file system, different versions. Everyone has different like abilities to